The binomial distribution is a discrete distribution. And what that means, what you are taking, what you're trying to find the probability of, the probability of a particular x, those x's will be countable. They're discrete. There's a fixed number of trials. Each trial only has two outcomes, success or failure. Outcomes are independent. The probabilities do not change. Here is your formula. Now this is what you're trying to find the probability of. This n is the number of observations. X, that's what you're trying to find the probability of. P, that's your probability of an event of interest. Or you may think of that as success. It's what you're trying to find, even though it may sound negative in some cases. Q is 1 minus P, and that's what we're not curious about. And I guess that's all I need to say. All right, now the way you find the mean of a binomial distribution, or the expected value of it, you just take n, number of observations, times your probability of success. And your standard deviation will be the square root, number of observations, probability of interest or success, probability of the one we're not interested in. Now, the next page is a table, and I'm going to come back to that. This is a oops, I didn't mean to do that. So this is a binomial distribution table, and this first column is values of n. Okay? And these numbers across the top are values of p. So in the problem we were talking about, we were working on, n is 5. So here n is 5. This is the only part of the table we're looking for. And then your x values are your second column. And in our problem, we were trying to find the probability x equals 3. So we're going to be concerned with this row. Across the top, as I said, those are your values of p. In our problem, p was 0.3. So I'm concerned with this column. Okay? So go down this column until you meet here with the row. So when p is 0.3, n is 5, x is 3, your answer is 0.132. 4 and 5. Our p has not changed. We're still at n equal 5, but we're looking at 4 and 5. I can't make that any bigger. 4 and 5 are these two, 0.028 and 0.002. 028, 002. If your p is given, let's say your probability of success was 0.45. You don't have a column that's 0.45, and so you do it by you'd use the formula. Usually your p's will be given, but just in case, store that formula in the back of your head. All right, let's go to the very last page. All right, now I'm going to change colors to green. 8. So I'm down here for n equal 8. My p is 0.8. I'm over here in this column. P is 0.8. And I'm looking for x equals 6. X equals 6.294 right there. So let's go put that in. All right, so we want 0 through 4. Our p has not changed. So there's that. 001, 009, and 046. Let's go back. There's not anything here, so there's 0. Okay? Okay, 6, 7, 8 are these. So I want these. 294, 336, 168. So this is just practice. Let's find the probability that x equals 3, and I'm given these values. So plug these values, substitute those values into your formula. So that will be 5 factorial divided by 3 factorial times 5 minus 3 factorial times p, which is 0.3, raised to the x, this is x is 3, q is 0.7, 1 minus p, and n minus x, 5 minus 3, which is 2. The sum of these two exponents, 3 and 2, will always give you n. All right, so to calculate this, if you're doing it by hand, we'll use technology or tables, but I'm going to go through a couple by hand because, and I'll tell you why in a minute. You can't always use your tables, but you can always use technology. This is 5 factorial over 3 factorial times 2 factorial, 0.3 to the third, 0.7 squared, and that's 5 factorial, well 5 times 4 times 3 factorial. I want to stop there because I want to cancel that 3 factorial in the bottom. That's 0.3 to the third, 0.7 squared. So those cancel, and 2 factorial is 2. 2 will go into 4 2 times. So you're left with 10 times 0.3 cubed, 0.7 squared. I used my calculator and got 0.1323. 1323. Now the next one, probability x is greater than or equal to 4. Well, this only goes up to 5, n is 5, but what would be probability of x greater than or equal to 4 would be 4 because you're including it plus probability of 5. So if you use the formula, this first one would be 5 factorial, that hasn't changed, over 4 factorial times 5 minus 4 factorial, p, which is 0.3 to the x. In this case, we're doing this one. It's 4. And 0.7 to the 1. Remember, those two exponents must add up to n. Plus probability x equal 5. Well, that's going to be 5 factorial over, that's n factorial over x factorial, which is also 5. And then 5 minus 5 factorial. And p is 0.3 to the 5th, 0.7 to the 0. This 5 minus 5 factorial is 0 factorial. 0 factorial is defined to be 1. So I use my calculator, 0.02835 plus 0.00243 equals 0.03078. Now, let's go back and talk about the table. P is 0.3 and N is 5. So, and that's what we got, 0.132, except I got 4 decimals and it did 3. Okay? Now let's look for 4 and 5. 028, 028, 002. So here on this page, I did it by hand, but we could always use our table if, let's go else. What we do, if 80% of the people in the community have internet access from their homes, find these probabilities for a sample of n equal 8. So sample of 8 people. So n equals 8. And my interest is people that have internet access at home, and that probability is 0.8. And we're going to use the table, not our formula. So the first one is probability x equals 6. X equals 6, n is 8, p is 0.8. Let's go back. 0.294. At most 4. Now what is at most 4? Well, that would be the probability x equals 0 plus probability x equal 1 plus probability x equal 2 plus probability x equals 3 plus probability x equal 4. So let's go back and look. 0 through 4. Okay, so let me go back and say. So that's going to be 0 plus 0 plus 0.001 plus 0.009 plus 0.046. And that gives me 0.056. At least 6. What's n? N is 8. Change colors again. That would be P at least 6. That would be x equals 6 plus x equals 7 plus x equal 8. All the way up to n. 6, 7, 8. 6, 7, 8. Let's go back and 0.294 plus 0.336 plus 0.168. And that gave me a total probability of 0.798. So the probability at least 6 of the homes have internet access is 79.8%. You know, just sometimes they'll ask for a percent. Sometimes the question will ask for a decimal.